So this is the third and final part of the units and significant figures lecture. So when we do arithmetic, how do we keep track of the significant figures? And remember, this is important because we want our final answer to be as precise as possible, but with no uncertainty. So when multiplying and dividing, the final answer should have the same number of significant figures or digits, I'm going to write digits, as the value with the fewest number of significant figures in the calculation. So for example, if we look at 1.023 times 4.56, 1.023 has 4 significant figures. I'm just going to write SF. And 4.56 has 3 significant figures. So that means our answer should have 3 significant figures. So if we put this in our calculator, we get 4.6648. But remember, we only need 3 significant figures. So the 6 is our third significant figure. We look at the 4. The 4 makes the 6 round down. So our answer is 4.66, which has 3 significant figures like it should. Okay, you guys try the next one on your own. Pause the video, and then you can restart and see if you're correct. So, 56.780 has 5 significant figures. 2.3 has 2 significant figures. So our answer should have 2 significant figures. So let's do the math. And we get 24.68695652. And that's everything that the calculator gave me. I just wrote the whole thing down. Okay, so 2 significant figures means where the 4 is. So we look at the 6. The 6 makes the 4 round up. And so we have 25 is our answer with the appropriate number of significant figures. Okay, for adding and subtracting, the final answer should have the same number of decimal places. So this time we're not talking about the number of significant figures. We're talking about how many digits we have to the right of the decimal point. And it should again be the fewest number of decimal places. So, for example, 5.67 has 3 decimal places. I'm going to write DP. And 1.2 has, and 5.6 does not have, 7 does not have 3 decimal places. It has 2 decimal places. Sorry about that. 1.2 has 1 decimal place. So our answer should have 1 decimal place. So when we add those 2 together, we get 6.87, and we want 1 decimal place. That's where the 8 is. So the 7 makes it round up, and we have 6.9. Okay, again, you should pause the video and try number 2 on your own, and then restart and see how it goes. So 10.047 has 3 decimal places. 3.45 has 2 decimal places. So our answer should have 2. Always the fewest number of decimal places. So when we do that subtraction, we have 6.597, and we want that rounded to 2 decimal places, which is where the 9 is. The 7 makes the 9 round up, so the 9 becomes a 10, but we can't put a 10 because that's 2 digits where there's only 1 digit. So that makes the 5 round up to a 6. So our answer to 2 decimal places is 6.60 because we have to have 2 decimal places. Okay, so what happens when you do both addition and subtraction and multiplication and division all within one problem? Well, we want to avoid rounding errors, so we never round intermediate steps. Always carry the full number of decimal places. And to keep track of the significant figures, you can just underline the rightmost significant figure. So for example, I have 4.562 times 3.99870 divided by, in parentheses, 452.6755 minus 452.33. So let's start by counting everything. So we have to follow the order of operations, which I know we haven't fully talked about yet, or maybe we did a little, but just to remind you, we do things in parentheses first. So let's do that subtraction first. So this one has 4 decimal places, and this one has 2 decimal places. So our answer should have 2 decimal places. Also, we can do multiplication and division from right to left as they come. So we're going to multiply these 2 numbers and then divide by whatever we get out of our parentheses, so we can go ahead and do the multiplication of these 2 numbers. So remember, when we're multiplying, we're not talking about decimal places like we are with addition and subtraction. We're talking about significant figures. So this first one has 4 significant figures. The second one has 6 significant figures. So our answer, when we multiply those 2, should have 4 significant figures. So let's do that and see what happens. So if we multiply those first 2 together, we get 18.242 0694. And remember, we said our answer from that should have 4 significant figures. So 1, 2, 3, 4. So we're going to underline the 4 so we know that that's where our significant figures are. Then we're going to divide by, we do the subtraction. So the subtraction is 0. That's a parenthesis, sorry, 3455, and we said its significant figures should be 2 decimal places, so that's also at the 4. So now we do that division. So we do the division, and we get 52.799,799,04313. Now we were dividing, so what is our number of significant figures? Well, the first one, remember, the 18.2 something had, had 4 significant figures. This second one, since it could only have 2 decimal places, it only has 2 significant figures. So the 4 and the 2, remember we always take the smallest, so we should have 2 sig figs after we do the division. So this equals 2 significant figures. That's where the 2 is. So we look at the 7. The 7 makes the 52 round up to a 53, and that's our final answer. Okay, you should try number 2 on your own. Pause the video, and then we'll go through it. Okay, so again, we do the addition first. So 44.11 has 2 decimal places. 1.223 has 3 decimal places. So when we add those, we should have 2 decimal places. Okay, if we go to do this multiplication, we have 5 significant figures times 4 significant figures, which gives us 4 significant figures. Okay, so on the multiplication, we get 53.2332. Sorry, that should have been in black. So 53.2332 divided by that addition, which gives us 45.333. Okay, now remember, we said the multiplication, we should have 4 significant figures, so that's the 3, because we should have had 4 sig figs. From the addition, we should have had 2 decimal places, so that's the 3. So we do the division, we get 1.174270399. Now when we divide, okay, the 2 decimal places means we have 4 significant figures, right? So that's 4 significant figures. And when we combine those 2, it means we have 4 significant figures. So our answer should have 4. 1, 2, 3. That's where the 4 is. 2 rounds down, so 1.174 is our final answer to the correct number of significant figures. Okay, you should be ready to try the homework for units and significant figures now.